Penang Island, Malaysia. This former British colony was always a vital stop for spice traders following ancient shipping routes. For centuries, boats and ferries were the only way to leave the island. Until 1985, when a 14-kilometer bridge linked Penang to the mainland. Flash forward 20 years, and traffic on the first Penang Bridge has reached a breaking point. 100,000 cars are crossing daily.
Saya menggunakan jambatan selalu jam. Saya pernah sangkut sampai 5 jam pun saya bisa.
A bold decision is made to construct a new bridge spanning nearly 17 kilometers over water. It will require 2 companies, one Malaysian and one Chinese, to work in lockstep to create a $1.5 billion bridge strong enough to endure for the next 120 years. But to build it will require battling the forces of nature.
Suddenly the crane already shaking, shaking like the devil,
Bumi ini bergoyang-goyang sekali, hati saya sakit sekali lah, takut.
If tsunami happen to come over, I think so that's it. Everybody's gone.
And unforeseen events.
Kawan I jerit, something want to fall down. I boleh manage buat emergency brake, then baru benda tu collapse lah.
If they overcome these hurdles, they'll have built the longest bridge in Southeast Asia. The second Penang Bridge. Envisioned as the longest in Southeast Asia, it will cross the Penang Strait to connect Batu Maung on the south end of the island to Batu Kawan on the mainland. It will ease crowding on the first Penang Bridge and bring economic growth to both areas.
Southern part of the Penang Island needs a development. Therefore, we should build another bridge from the south of the island.
For this bridge, the engineers have merged 2 bridge designs. The first, a box girder bridge more than 16 kilometers long. This is the approach span. The second, a shorter but more prominent cable stay bridge, is called the main span. To get this sea-crossing bridge exactly right will require skilled coordination between 2 construction teams. China Harbor Engineering Company, or CHEC, from China, and UEM builders from Malaysia.
在项目合作的初期，确实有过很多的争论和争吵。
And the Malaysian government has set up a special company to manage the massive project. Dr. Ismail Mohammed Taib is the man in charge.
We have to be the referee all the time. We have to mediate to ensure that what they do must be beneficial for the overall completion of the job.
Ismail 先生呢，他非常严肃，要求也很高。
CHEC is in charge of the bridge's foundation, called the substructure. Over 5,000 piles driven below the seafloor and 586 piers. The superstructure for the approach span is UEM's job. Over 8,000 concrete box girders joined together to form the road deck.
This is one of the unique construction in the world where the split is horizontal. If you are careless, you might end up with superstructure actually not following the alignment of the substructure.
The CHEC crew alone will build the cable stay bridge. For the substructure here, the team will bore 120 meters into bedrock, some of the deepest bridge foundations in the world. For its superstructure, they will anchor 144 cables to the road deck and string them through pylons that rise 90 meters in the air. Located at the deepest section of the Penang Strait, this is also the highest point of the bridge, with a 30-meter clearance to allow ship passage below. But here, it's also the greatest danger of a ship collision. And without protection, an accident here could weaken the bridge with possible catastrophic results. To safeguard the pylons, the pile caps that form their base are built with giant steel fenders, packed with formwork and a special concrete that can repel saltwater's corrosive effects.
For our pile cap construction, the volume is up to 2,500 tons. It requires huge volume of concrete at one time.
To get that much concrete out at sea, the crew brings in their own floating concrete factory. It operates continuously for over 3 days straight.
You need to make sure the mixing plant is working well. Sometimes the pipes will be blocked. Sometimes the material is not well mixed. Challenges are there.
The Malaysian heat adds another challenge. Workers struggle to keep the concrete below 36 degrees centigrade. A hotter pour would risk the concrete shrinking as it hardens, potentially leading to structure failure and bridge collapse. To battle soaring temperatures, bags and bags of ice are brought to the batching site to cool the water for the concrete mix. But bags of ice are not enough.
You need to take extra input to reduce the temperature from outside.
Water pipes are embedded within the pile cap structural reinforcement, constantly cooling it while the concrete flows.
We place the cooling pipe inside the concrete to reduce the internal temperature, and the concrete will be under control.
After pouring concrete for more than 48 hours continuously, the first of the pile caps for the main span is finished. While Jason and the Czech team focus on the bridge's cable stay main span, the UEM crew on land are building the box girders that will form the road deck for the long stretch across the sea. A vast prefabrication factory reaching as far as the eye can see is set up to produce thousands of box girders.
Building more than 8,000 segmental box girders is not an easy task. We set up this factory with all the equipment, and it covers about 50 acres, which is more than 50 football fields.
Each box girder begins with 6 tons of rebar, cut and tied together into a frame. The steel frame is transferred to a mold with a giant crane. Each girder soaks up to 5 truckloads of concrete.
The challenge here is to make sure that the concrete is waterproof. The marine environment is very aggressive. It corrodes steel. If seawater gets to the steel, the rusting process will start. The steel will expand and it will break the concrete.
To add to the challenge, each of these box girders need to be tailor-made.
Each segment will only fit into one particular location in the bridge. It's almost like an individual person. It's got a specific shape, specific gradient built into it, and it's got specific inserts in it.
The S-curve in the bridge requires that each block is engineered individually, so it will fit perfectly in this immense jigsaw puzzle. But there is a problem. Girders are coming out of molds pocked with holes and lined with cracks. Subpar girders could spell disaster.
It was really difficult actually when UEM was starting their casting. Every segment they cast, we rejected them because of the poor quality of the segments.
The situation is severely delaying construction. The crew is making only 3 bridge-worthy box girders a week. They need to produce 30 times that amount.
Right at the beginning, it was very, very slow. We were casting 2 or 3 segments per week sometimes.
At this pace, it will take more than 75 years to cast enough box girders. There's neither the money nor the time for this sort of trial and error. Something must be done, or there will be no second Penang Bridge. More than 8,000 box girders must be joined together to create the approach span, the longest stretch of the second Penang Bridge. But the girders are coming out of the molds riddled with honeycomb-like air bubbles. The defective ones have to be destroyed and the bridge is falling behind schedule.
We were not making any payment at all to them.
UEM Senior Manager Premakantan is called in to troubleshoot the dire situation. He discovers there's a problem with the concrete mix.
We have consulted concrete experts worldwide. We brought them here actually at considerable expense, and we have had them look at the issues and give their opinions and calculations and engineering input. With that, we resolved all these issues.
Premakantan faces another challenge. The box girder crew comes from more than 6 different countries, many of them inexperienced.
You got 500, 600 workers to train. Not all of them have done this kind of work. It has to be a short learning curve, but it's a difficult learning curve.
Finally, Premakantan gets everything in sync.
5 months from the beginning, we resolved all these issues. And from then on, it was just looking forward all the way.
From 2 to 3 segments a week, the team goes to 10 to 16 segments a day. Defective girders aren't the only obstacle to completing the second Penang Bridge. Well into construction, concerns are raised about the bridge's ability to withstand an earthquake. 26th December 2004, a 9.3 magnitude earthquake hits the west coast of northern Sumatra. Tremors are felt in Penang, and a deadly tsunami slams the island. Malaysia is not known as a high-risk earthquake zone, but there's been an increase in seismic activity in the country recently.
We are not very far, from all this actively seismic area of the world. So therefore, we shouldn't be complacent, and then we should take all the precautions necessary, especially to protect the important structures.
Dr. Ismail isn't taking any chances and decides to make the second Penang Bridge one of the most earthquake-proof bridges in the world. He finds Dr. Kamarudin Malik, an expert in large structure earthquake protection.
The containers, the piling that they had constructed and that they had designed then could not take the earthquake. So they have only 2 options then, One is to strengthen the piling, which cost them more money, and then lengthen the construction period. And number 2, they could use high damping rubber bearings, which not only could protect the piling, but also it can protect the superstructure. Superstructure here means that the decks, yeah?
Dr. Kamarudin demonstrates how high damping rubber bearings work.
Using these model of structures of different height, this is maybe you can consider 1 or 2-story structure, or even a bridge. 5-story, 10-story, or 20-story, or maybe this one you can consider to be Petronas Twin Tower, 88-story. I'm going to simulate an earthquake, and we'll see how these structures of different height will respond.
You might think the tallest would shake the most, but it's the shortest.
All structures, whether low or tall structures, they have what we call natural frequencies. Imagine, right, if you are tall enough, strong enough, right, you are standing beside the Petronas Twin Tower. You push the Petronas Twin Tower at the top and you release. You can see Petronas Twin Tower now is moving at its what we call natural frequency. And people have calculated it's about 0.1 hertz. So it's a very low number. So now we go to this structure that responds the most to the earthquake. It vibrates faster. So that is about 3 or 4 hertz. The damaging frequencies of the earthquake typically between 2 to 6 hertz. So what happens is that when the earthquake hits the Petronas Twin Tower, the natural frequencies of this building is not within that window of damaging frequency of the earthquake. So nothing happened to this building. Because the natural frequency of this structure is about 3 or 4 hertz, within that window of damaging frequency of the earthquake, 2 to 6 hertz, then what happens is that the process of what we call resonance effect takes place. In other words, amplification of the response. because the natural frequency of this is more or less the same as the nature of the earthquake frequency. When we put rubber bearings underneath this building will now behave like a tall structure. So that is the function of the rubber bearings. We change the natural frequencies of the structure from 3 to 4 Hertz to typically 0.4 Hertz, 0.5 Hertz. That is the function of the rubber bearing. This building will no longer behave like this, it will behave like this, very slow.
Technological specifications are developed by Dr. Kamarudin and his team at the Malaysian Rubber Board's Tun Abdul Razak Research Center in the United Kingdom. The high-damping natural rubber bearings are then manufactured in a factory 300 kilometers from Penang.
These devices consist of laminates of rubber and metals. It's unique in the sense that it is semi-intelligent. Under normal circumstances, there are no earthquakes. The bearings are very stiff, but the minute the earthquake comes, the bearings automatically become soft. When it's soft, it will automatically isolate the vibration or the energy of the earthquake from being transmitted to the structure.
Once installed, the more than 1,300 rubber bearings help ensure the bridge is earthquake-proof. They're now ready for the box girders that will form the road deck. The 100-ton girders are loaded on barges capable of carrying 700 tons. But there's a huge problem. The water is less than 1 meter deep in places. That's much too shallow for the barges and could bring construction to a halt. Something Dr. Ismail and the team cannot afford. The box girders sit waiting at the mainland plant, but the crew can't get them to the piers. The water is too shallow for the barges. The only solution available? Dredging the sea. The Chinese team, Czech, uses power shovels to create a 200-meter wide channel, just enough space for 2 barges. But it's a narrow passage.
The difficult part actually was when we had common usage of the dredge channel. Czech has already built the structures on one side. On the other side is mud flats. We have to have, at any time, capability for 2 vessels to pass by, towing barges. And barges are not very easily controlled with the tidal currents.
One go isn't enough. The huge shovels must operate throughout the construction process.
Theoretically, you dredge once and that's enough. But unluckily, we are finding that the channel silted up very fast. So we have to do a lot of maintenance dredging.
To keep the barges running smoothly, some 12 million cubic meters of muck and silt, the equivalent of 4,800 Olympic-sized swimming pools, is removed and returned to the ocean more than 20 kilometers away. On the approach span, 4 custom-made specialized cranes called launching gantries lift the girders and hold them in position for the deck-building crew. The launching gantries build the bridge, span by span.
The launching girders is the most important thing for us to proceed with the bridge. Without these launching girders, we can have all the segments, but we can't put the segments right on top of the piers.
Each barge, carrying up to 5 girders, is positioned below the launching gantry and steadied by a holding barge.
We can maneuver the holding barge, which also maneuvers the segment delivery barge.
One wrong move could result in a fatal accident. A specially trained team maneuvers a series of ropes to place the barge in the precise position. A winch attached to the launcher lifts the 100-ton blocks. The mammoth crane will lift 14 girders from pier to pier. The segments are joined with super-strength adhesive and high-tensile strength steel cables that are stressed to the limit. Now there's one giant span between the two piers, and the launching gantry moves forward and repeats. As UEM builds the approach span, the Czech team, led by Jason Lee, are racing ahead at the main span. Two pylons towering over 90 meters, the height of a 30-story building, will support the cable stays. More than 600 tons of steel is used for the reinforcement of each pylon. As they build the pylons, the Czech team simultaneously erects temporary steel supports to install the crossbeam. With an enormous drop, constructing the steel supports is a perilous task.
When you try to lift the steel tubes, how can you make sure that these tubes can be lifted properly? And also all these tubes need to be welded one by one. The safety, there could be a problem.
The massive crossbeam serves as a tie for the two towers and is the starting point of the road deck. The main span deck is built incrementally, using traveling formwork. With each deck segment cast, a stay cable is installed. Multiple steel cables are strung through long-density plastic tubes, anchored to one side of the deck, run up and through openings in the pylons, then dropped back down and anchored to the deck's other side. Every cable is individually stressed to its maximum strength. Fully installed, the 144 cable stays have a combined braking strength of over 210,000 tons. That's enough to hold back over 200 jumbo jets at full throttle. Another challenge is Malaysia's capricious weather. The bridge must be strong enough to withstand these same forces. This is where these tubes come in. Each is designed with a thin lip called a strake that spirals from end to end. This protects the inner cables from corrosion and breaks up any assault of rain and wind that could induce vibrations and weaken the bridge. 11th April 2012. Malaysians are celebrating the installation of a new king. But at the main span, the crew is focused on the job at hand. 3:30 p.m. Tower crane operator Ramaturai Kanan gets the shock of his life.
Suddenly the crane already shaking, shaking like the devil, Then I pray lah.
Tremors are felt all around the island.
Sangat bergetar sekali, dia bumi ini bergoyang-goyang sekali, hati saya sakit sekali lah, takut.
An 8.6 magnitude earthquake has hit the west coast of northern Sumatra, just 419 kilometers away. The fear on everyone's mind is that of a killer tsunami.
The site is about, I can say, about 800 meters from the sea. And if tsunami happen to come over, I think so that's it. Everybody's gone.
April 2012. An 8.6 magnitude earthquake has hit the west coast of northern Sumatra, not far from where a massive earthquake struck in 2004. It sent tremors throughout Southeast Asia and spawned a deadly tsunami that hit Penang, and another may be on its way. The box girder factory is right on the water's edge. Nearly 1,000 employees live and work here. Supervisor Anwar Abdul gets an urgent SMS.
I received an SMS asking me to evacuate all the workers from the site.
The earthquake triggers a tsunami warning across the Indian Ocean. Killer waves could hit Penang within a couple of hours.
We were very, very close to the shore here, and it's all tidal flats here. And in any tsunami event, the water will rise up very high. So my main concern was loss of life.
Evacuating an area that is larger than 50 football fields is not easy.
All work was dropped, stopped all work. Everyone gathered at the gathering point.
aba-aba dari bos harus semua orang harus lari-lari cari tempat yang aman.
But there's no place to run. The area surrounding the factory for miles is completely flat.
We pressed every vehicle that we had into service to transport these people out. Then again, you look at the surrounding, it's all flat. How far do you transport them? I don't know how far inland the tsunami is going to come. So finally, we got the idea. We contacted the stadium authorities. You know, they are then about 6, 7, 8 meters above any potential water level.
It's 5 o'clock, and there is just 1 hour to complete the mission. They must transport nearly 1,000 workers to the Batu Kawan Stadium, some 5 kilometers away. By 6:30 p.m., everyone is safe at the stadium, along with another 1,000 people from the surrounding area.
Di sana sekitaran ada 4 jam atau 5 jam.
Everyone anxiously waits. At 10 p.m., authorities finally lift the tsunami warning. But it doesn't mean the earthquake hasn't impacted bridge works. One pier, cast with concrete just 2 hours before the earthquake, provokes concern. Construction manager Yusuf Musa takes a closer look.
We found out there's a crack along this line.
Every bridge in the world has cracks, but those that are too wide or too deep will weaken the bridge. Yusuf conducts tests to determine if they must destroy the pier and start again. They extract a core to determine the damage.
We have to check how severe is the crack.
Yusuf puts the core sample under a microscope to assess the width and the depth of the crack.
The severity is so much that we need to do the remedial for the crack.
The solution? Concrete injections, powered into the cracks to seal the fissures. But it's not just this pier that must be thoroughly inspected. Dr. Ismail has called in extra help to make sure nothing is missed. An independent team of engineers, led by Matt Carter, monitor progress and ensure every centimeter of the bridge meets the highest standards.
We come here every 2 months to spend a couple of days looking over the site with the client and the contractor, checking that the quality is to standard and that what's being built is what should be built.
Matt was there when box girder production was stalled.
It's important to understand about a bridge like this is it's very much a unique, bespoke project. So there's always a learning curve. For sure there might be some quality issues, so you need a quality control system in place to identify those issues, and then the construction team needs to take that seriously and improve over the course of the project.
And improve they have. On 20th December 2012, Primakantin's box girder construction team cast the last of the 8,092 segments. It's a proud day for all.
It's like a baby. It was handed to me with chicken pox. So I managed to cure it, and it's grown into a healthy adult today. Today it graduates. Today it's 18 years old, and we're completing the casting today.
This is about 100 days ahead and more than 1,000 segments ahead of the schedule.
But all will be for naught if the main span decks don't match up exactly. The two decks have been inching forward across the Straits of Penang day after day, week after week, for a full 9 months. When the last cable stay is attached, they are just 3 meters apart. By April 2013, the second Penang Bridge reaches a critical stage. The big question, will the decks make a perfect match for final closure?
For large span of Cape Stay Bridge, under such condition, the structure is quite flexible due to the wind or temperature effect.
Surveyors constantly monitor the progress to make sure it matches the design plans.
因為佢個好多嘢咧係設計規定嘅，呢個橋嚇，如果你錯咗，你就會偏離，就會同人哋個接唔上。
In spite of all their efforts, there's a problem. A 30-millimeter difference between the two sides. The engineers have a surprising fix. Water. Tons of water. A pool on the lower deck is filled with 100 tons of water, while another pool on the higher deck is filled with 150 tons.
They use the water as a counterweight. So after they put in the weight in this way, it's the other way around.
It's complicated maneuvering to get the perfect fit. Workers fasten down a giant clamp to hold the deck segments together. Engineers must now wait for the cool of the night before they pour the concrete. A special prayer is held on the bridge to commemorate the completion of the main span.
This is the closure pour for the whole bridge. This is important because we have actually achieved the final structural connection between Batu Kawan and Batu Maung on the other side.
As they pour the concrete, they gradually release tons of water over the deck.
Now water is being siphoned out to balance with the concreting, and this will actually balance the out of tolerance.
At last, the bridge meets, linking all the road deck segments together for the entire 16.9 kilometers across the sea.
Today, the bridge is finally closed. We have been working on this project 3 years ago. At that moment, nothing was here. Now you can see a bridge is standing here. Personally, I'm very much excited and also very proud that we can be here to share with the Malaysian people, our team, this magnificent moment. We are so much proud.
It's a major achievement, but a tragedy awaits. 6th June 2013, Penang Island, peak hour traffic. A bridge ramp is under construction by a third-party contractor working independently from Czech and UAM. Tilasheni is driving home from work with a friend.
We are in a deep conversation lah. Now we are laughing. Masa tu one big metal piece jatuh dekat cermin dan pecah. Dan kawan I jerit, something want to fall down. I boleh manage buat emergency brake. Then we automatically lari dari kereta lah. Dan baru benda tu collapse lah.
Were there any other vehicles ahead of her? And if there were, did they make it to the other side? 6th June 2013. The main span is complete, and the second Penang Bridge is due to open in 3 months' time. Khairul Aizat is supervising construction on a ramp that links the island to the bridge. Suddenly, he hears a large crack.
Mungkin bahaya akan berlaku lah. So panggil semua kerja konkrit. 3 orang sempat mari, lagi 2 orang tak sempat. Dan sekelip mata dia jatuh terus.
Saya sudah lari, tapi itu jembatan itu sudah runtuh. Saya ikut ketimpa semua lah itu dekat jembatan itu. Tahu-tahunya saya sudah di bawah. Waktu jatuh itu kan macam mabuk itu kan banyak itu. Asap itu keluar. Orang pun nak cari saya tuh susah. Saya keluar sendiri. Lepas itu saya keluar tuh langsung pingsan saya.
Rescue teams are immediately dispatched to the scene. A 30-meter section of the unfinished ramp has fallen 18 meters over a dual-lane trunk road.
Rasa macam terkejut kerana pembinaan jabatan yang baru dalam pembinaan tiba-tiba berlaku satu runtuhan. Mereka sampai dan membuat size up di tempat kejadian. Masa itu ramai pekerja-pekerja yang pulang daripada tempat kerja. Jadi saya beranggapan bila berlaku satu runtuhan yang besar, berkemungkinan banyak masa-masa yang terperangkap di bawah runtuhan tersebut.
The wreckage is immense. There's no way to see if anyone is trapped in the rubble. Rescuers must rely on people like Tilasheni who were there when the collapse occurred for details.
Kami nampak sebelum tu ada satu motosikal dengan satu kereta.
But no one knows how many people may be buried in the wreckage. At almost 300 tons, the rubble weighs more than 3 737 airplanes. A giant crane attempts but fails to clear the wreckage. They work through the night, and at 12:40 a.m. they discover the smashed corner of a car.
Bayangkan dengan keadaan masa yang terperangkap, sama ada masa telah meninggal dunia, cedera ataupun masih hidup. Ini merupakan satu semangat bagi pihak Jambatan Bomba untuk nak menjalankan kerja-kerja operasi dan menyelamat secepat yang mungkin.
The rescue teams push forward.
Tengok, ada tak kisah-kisah mangsa, kenderaan ke, sandara ke. Keluar mana yang boleh dulu, keluar, kita masuk. Ini safety pasal.
They find a broken number plate and call out for people with missing families to come forward. The Department of Occupational Safety and Health, DOSH in Penang, is keeping a close eye.
About 1 hour after the incident, then I start to gather my men, and we rush to survey the area and got whatever basic information regarding the incident for us to start our investigation.
The ramp collapse raises grave concerns, and DOSH issues a stop work notice with immediate effect. They need time to conduct a full investigation into the cause.
In our investigation, we will focus definitely the failure of the support for the formwork, and how they install them, and also how they maintain it.
No stone will be left unturned.
After the investigation, if we have enough evidence that they break our law, definitely we will take them to the court or we charge them.
Though they work through the day and into the next night, the rescue team seem no closer to the crushed vehicle. They call in an excavator to pull away mangled formwork. Laudin Zainal Abidin arrives at the ramp, concerned that his brother did not come home last night, and that the found number plate matches his brother's car. He waits anxiously.
Tarik, tarik, tarik!
25 hours after the collapse, Tajuddin Zainal Abidin is found slumped over the dashboard of the car, crushed by a beam. His brother is both grateful and overwhelmed with grief. The rescue team continue through the night and the following day to search for other victims.
Kita masih buat lagi kerja-kerja search and rescue dengan menggunakan unit kenai, dan kita dapati unit kenai tidak menemui apa-apa lagi mangsa yang berada di bawah runtuhan tersebut.
Tajuddin Zainal Abidin's death is the only casualty, but the accident means a delay in the completion of the bridge. How long will DOSH take before allowing the construction to move on, if at all? A major ramp under construction by a third-party contractor working independently from Czech and UAM collapse. In response, the Department of Occupational Safety and Health, DOSH in Penang, issue a stop work notice to investigate.
They look at what are the possible causes. Design, installation of temporary support. We do some analysis on the ground. We call in eyewitnesses and 60 plus people, to get statement.
The result? The contractor and subcontractor building the ramp are charged for failure to undertake safety measures during construction and ensure worker safety.
So the case now is ongoing, and hopefully we will have a very positive result.
Satisfied sufficient safety measures are now in place, Dosh lifts the stop work order. The ramp can be completed and construction enters its final phase.
The most important thing for us is actually to confirm the structural behavior of the bridge.
At the main span, the bridge is designed to support 1,200 tons. The bridge must match these specifications, and there is only one way to check: a load test. An array of high-tech sensors track the bridge's movement, called its deflection levels, as it's placed under enormous stress. 17 trailers with a combined weight of 595 tons drive to the midpoint.
The monitoring shows that the maximum deflection is only 25 mm, whereas the consultant calculated previously is 31 mm. So that shows the bridge is actually much stiffer than it was designed for.
By early December 2013, the collapsed ramp is restored. And in the wake of the accident, Dr. Ismail insists on another load test to assure the public that the entire bridge is safe.
We've loaded to 360 tons, basically 15 24-ton lorries. Simple passenger vehicle is 1 ton to 1.5 tons, so that's a lot of weight in a short area. What we've found is that the bridge is behaving as expected. Deflections are actually less than we expected, so we're pleased with the results, and overall I think it's been a good and smooth operation.
1st March 2014, the second Penang Bridge is finally completed and ready for its public launch.
因为中国政府和马来西亚政府把这个项目放在两国合作框架下，这是一个历史时刻。所以，我们中国港湾的员工有这么一个千载难逢参与的机会，都感觉到非常骄傲和自豪。
It is a picture of 1,000 words. We are all very excited and very proud of what we have done here.
Malaysians are eager to try out the new bridge, and thousands have started queuing to make sure they are the first on the bridge. Tonight is a special night for Dr. Ismail.
Today is definitely very momentous. We have been waiting for actually 5 years to come to this point. And finally, the bridge is going to be open tonight. So definitely, I feel very, very happy.
Kita menyaksikan majlis peresmian sebuah projek mercu tangga yang tetap akan menjadi lambang kebanggaan rakyat Malaysia dan warga Penang. Saya dengan ini meresmikan pembukaan jambatan Sultan Abdul Halim Muadzam Shah.
Announced just this evening, the new name honors the current King of Malaysia. The second Penang Bridge, the longest bridge in Southeast Asia, is now complete. Building it required false starts, battling the elements, and perseverance. But now the sleek bridge that connects the island to the mainland with its gentle curve is a source of pride to those who built it and many who travel its distance.